Students, here I will explain about ionization potential or ionization energy or ionization enthalpy. All are same thing. Ionization potential, you know, amount of energy needed to just remove one electron from the valence shell of an element is known as ionization energy, ionization potential or ionization enthalpy. Students, if a element easily donate electron, its ionization energy will be less. Okay, so you just remember this thing, you need to provide the energy. Okay, means energy will be given, understand? In this case energy will be given, but for the electron affinity, electron energy will released. Okay, in this case energy required, so just that is the main difference between this and electron affinity. The energy required to remove one electron from neutral isolated gaseous, you need to remember this thing, neutral isolated gaseous atom. Okay, the atom should be neutral, isolated and gaseous medium. All the reactions happens in the gaseous medium. Okay, you just remember this thing. For gaseous state all the description will be there. If in solid state, then lattice energy will be a factor. So lattice energy, what that you will learn in the senior class. So that's why in gaseous state you need to count this thing. Okay, so that is the thing into a, so if electron will remove, that means that is form a positive charge will come. So if one, so students, one electron you can release remove, two electron you can release, you can know sodium, for sodium 281, for magnesium 282. So for sodium one electron easily it will remove, then to 28 configuration further. So first electron remove is called ionization potential 1 or IP1 or IE1. Okay, it will designated like this way. IP1 means first one electron will remove. Now IP2 ionization potential 2 means second electron will remove. So if you compare, students, I will explain over here, then you can understand. For sodium and magnesium, just students see, one electron sodium easily see, so IP1 will be very less, means little bit energy you give, it will release first electron because it will gain the noble gas configuration. But if you want to remove the second electron, then you need to remove it from this 8, you need to break its noble gas configuration, and you know second ionization energy for sodium is very high, lots of energy you need to provide, generally it will not shows. Okay, so that's why sodium always show valency 1, and it's very hard. If you give extreme pressure, that also it will it's not tends to so break this configuration 2-8. Similarly, student, for magnesium, first you give some energy, its IE2 is very less than the IE1. Okay, I hope I can make you understand. 282 means first electron it will remove, I know it will release first electron, you give some heat, but second electron it will rapidly release, because after releasing second electron it is gaining the noble gas configuration. So if you know the electronic configuration, students, easily you can explain the ionization energy, atomic size, everything, students. If you forget everything, because you know periodic table, you need to memorize lots of things, you need to memorize, because there is lots of exceptions. So if you remember the electronic configuration and atomic number, that's why I told to remember maximum possible atomic numbers. And I told you it's better to remember the S and P block elements whole. Transition elements, it's not they are that much in your class, but you need to remember whole S block and P block element, then it will be good, their position. So you just think their position and you can apply your common sense to get the answer. Okay, so here you can see the first ionization energy for the magnesium is little bit energy will be is greater than the second, because rapidly it will release the second electron to gain the noble gas. So that is the thing your idea is to give for the calculation of ionization potential. So ionization potential also depend on atomic size and nuclear charge. You can see greater atomic size, less ionization energy, because you know lesser force of attraction, so you know ionization energy less. But higher nuclear charge, more ionization energy, because you know it will not release its electron, it will accept its electron, higher nuclear charge means. So that's why greater energy required to remove one electron. That's why greater ionization energy. Now students, across the period you can easily understand. Across the period, left to right nuclear charge increase. That means ionization potential also increase. You can see the value 2000 and here 520. Okay. So because according to the group, you know, nuclear charge prefer, and according to the according to the period, nuclear charge prefer, according to the group, atomic size prefer. That's why ionization energy less. You can see according to the period, lithium ionization energy 520, but here 374. All I am talking about first ionization energy, IE1, not second or third. Second, third ionization energy also there, but that not that much is not to your syllabus. You just remember. Now students, electron affinity, you know, that's just reverse of ionization energy. Now just one electron they will accept energy release, converting neutral gaseous isolated atom into a negatively charged gaseous anion. Okay, so you can easily now coming in your mind the halogen series. J halogen has high electron affinity, and it's correct because nuclear, you know, atomic size increase means electron affinity decrease. You know, if ionization energy increase, electron affinity will decrease because both are reverse. One will gain electron, another will accept. One gain accept same thing. So gain or one another is electron release. So now students, you understand, if you see the table, you know, variation electron already students value, experimental value has given, because you know these are experimentally calculated, so you need to memorize. If there is some exceptions, you need to remember, but general trend showing that left to right horizontally atomic size decrease, nuclear charge increase, that means electron affinity increase. Okay, electron affinity increase. Okay, so left to right electron affinity increase. Here see it is plus value. Okay, so plus 48 means releasing its energy. No, here minus, sorry, that noble gas, don't go to the noble gas right now. Up to 17, minus 38 means here you can see for lithium it is releasing 60 value is I think kilojoule per mole, kilojoule. For fluorine it is releasing 328, so more electron affinity. Similarly student, down the group which is paper, atomic size increase means electron affinity less, so down the group electron affinity will decrease. That's why you see for hydrogen electron affinity 73 kilojoule, but for minus sign means it is releasing, that's why electron affinity is higher. Okay, means accept the electron and electron energy release takes place. In this case the value will be positive, that's why nothing is mentioned below before. Positive means that because energy you need to provide. Okay, and releasing means it will in new UPAC sign convention, energy release means it will denoted in minus sign. Okay, in a reaction right side it will be minus 20 joule means it will release 20 joule exothermic, and plus sign means endothermic. Okay, according to the sign convention. So that is the thing students. Here electron volt, or here you need electron affinity is represented by negative sign. Okay, so you understand negative sign, it is represented by. So that is the thing student. Next class I will explain about electronegativity. Thank you.